Question 2 of this exercise says, formulate the following problems as a pair of equations and hence find their solutions. So we are given these 3-word problems, and in each problem we have to formulate a pair of equations for the given situations and find the solution for that pair of equations. So let's start with the first part. The first part says that Ritu can row downstream 20 kilometers in 2 hours and upstream 4 kilometers in 2 hours. Find her speed of rowing in still water and the speed of the current. So the two unknowns in this situation are the speed of rowing in still water. So imagine that Ritu was rowing in a lake, rowing her boat in a lake where the water was not flowing at all. The speed of the boat in that case would be the speed in still water. So let's call that speed x kilometers per hour. So that's one unknown, x kilometers per hour, and the other unknown is the speed of the current. So let's assume that the speed of the current is y kilometers per hour. So the two unknowns in this situation are x and y, the speed of rowing in still water and the speed of the current. Now the fundamental concept in any such problem is how the speed of the boat changes when you're going downstream and when you're going upstream. So let me show you a figure that will help you think better. So imagine that this is the river in which Ritu is rowing, and imagine that these arrows represent the flow of water, the direction in which the water flows. So this direction in which the water flows is the downstream direction. And when Ritu is rowing, so let's say this is Ritu's boat, and when Ritu is going downstream, her speed will increase compared to x, because the speed of the current will get added to the speed of rowing in still water. So when going downstream, Ritu's speed will be x plus y kilometers per hour. The speed of the current will add to the speed of the boat in still water. On the other hand, if Ritu is rowing upstream, so let's say this is Ritu and she is rowing upstream, so she is trying to go against the direction of the flow of water, in which case the speed of the current will reduce Ritu's speed compared to x, and the speed upstream will be x minus y kilometers per hour. So the speed of the current will get subtracted from the speed of the boat in still water. So remember this, when going downstream, the two speeds get added. So we have the speed of x plus y kilometer per hour with respect to the ground. So if someone was standing on the ground, they would see Ritu's speed as x plus y kilometers per hour if she was going downstream, and if she was going upstream, they would see her speed as x minus y kilometers per hour. So this is the concept that we have to use to solve this problem. So let's come back to our problem. So the statement says Ritu can row downstream 20 kilometers in 2 hours. So distance is 20 kilometers. So 20 kilometers, and speed is going downstream is x plus y kilometers per hour. So x plus y kilometers per hour, and we know that distance by speed is equal to time, and the time given is 2 hours. So this should be equal to 2 hours. So from this equality we can get our first equation in x and y. Just cross multiply this x plus y to this side and divide 20 by 2. So we will get x plus y is equal to 10. So this is the first equation that we get in x and y. Similarly, when Ritu is rowing upstream, she can row 4 kilometers in 2 hours. So distance of 4 kilometers, and the speed when she's going upstream becomes x minus y kilometers per hour, and this time is again 2 hours. So she can do this in 2 hours. So this will give us our second equation in x and y. So again cross multiply x minus y to this side and divide 4 by 2, and that will give you x minus y is equal to 2. So now we have obtained two linear equations in x and y. Now all we need to do is to solve this pair and get the values of x and y. So we see that the coefficients of y are 1 and -1. So let's just add these two equations. So if we add these two equations, what do we get? We get 2x on the LHS, and on the RHS we get 12. So this gives us x is equal to 6. And now substituting this value of 6 into any of these two equations, we get the value of y. So if we substitute this into the first equation, x plus y equal to 10, we will get 6 plus y equal to 10, and this means that y is equal to 4. So x, which is the speed of rowing in still water, this is equal to 6 kilometers per hour, and y, which is the speed of the current, this is equal to 4 kilometers per hour. So Ritu can row her boat in still water at 6 kilometers per hour, and the speed at which the water flows in the river where Ritu is rowing, that speed is 4 kilometers per hour. So this is our answer. In part 2 of this question, the problem statement says 2 women and 5 men can together finish an embroidery work in 4 days, while 3 women and 6 men can finish it in 3 days. Find the time taken by 1 woman alone to finish the work, and also that taken by 1 man alone. So this type of situations come up often in problems related to time and work, and I have often found that students find it quite confusing to solve such problems. But the thing is that all such problems are really easy to solve because they are based on simple application of unitary method or proportions. So as I solve this problem, follow my argument or my reasoning carefully. And if you understand this reasoning, you'll be able to easily solve any similar problem quite easily. So the two unknowns in this situation are the time taken by 1 woman alone to finish the work and the time taken by 1 man alone to finish the work. So let's assume them to be some variables. So let's say that the time taken by one woman alone to finish the piece of work is, let's say, x days, and let's assume that the time taken by 1 man alone is to finish the piece of work is y days. So the two unknowns are x and y, and these unknowns are what we have to find. Now the key idea here is to think about how much work or what fraction of the work can 1 woman alone do in 1 day, and what fraction of the work can 1 man alone do in 1 day. So if 1 woman alone takes x days to finish the whole piece of work, we can say that in 1 day 1 woman can finish working alone. She can finish 1 by x fraction of the work. So for example, if 1 woman alone can finish the work in, let's say, 40 days, then in 1 day she can finish 1 by 40th of the whole work. And the key assumption we are making is that the rate of working is uniform across all days. So if someone's taking 40 days to complete a piece of work, we assume that they can complete 1/40th of the work in 1 day. But this is not very realistic because typically this is not how work happens. Sometimes you work fast, sometimes you work slow. But in such problems, this assumption is the best that we can do. So in 1 day, 1 woman can finish 1x fraction of the work, 1 by x fraction of the work. And similarly, in 1 day, 1 man alone can finish 1 by y fraction of the work, because 1 man alone is taking y days to finish the whole work. So in 1 day, 1 man can finish 1 by y of the work. Now, what does the problem statement tell us? It tells us that 2 women and 5 men can together finish an embroidery work in 4 days. So how much work can 2 women and 5 men do in 1 day? So here's the key idea. So 1 woman can finish 1 by x fraction of the work in 1 day. So 2 women can finish 2 by x fraction of the work in 1 day. And again, we are making an assumption here that all women work at the same rate, and all men work at the same rate, but in reality that's not how it typically is. But in such problems, again, this is the assumption that we have to make. So in 2 women working together can finish 2 by x fraction of the work in one day, and similarly 5 men can finish 5 by y fraction of the work in one day. And if these 2 women and 5 men are working together, they can finish 2 by x plus 5 by y, this much fraction of the work in one day. So for example, if 2 women can finish 1/10 of the work in one day and 5 men can finish 1/5 of the work in one day, then together they can finish 1/10 plus 1/5 of the work in one day. So what is this fraction? Well, the 2 women and 5 men can finish the whole thing in 4 days. So in one day they can finish 1/4 of the work. So 1/4 of the work is their total output, the total output of 2 women and 5 men. So this means that 2 by x plus 5 by y is 1 by 4. And this is the first equation that we get in x and y. Now the second piece of information says 3 women and 6 men can finish this work in 3 days. So 3 women can finish 3 by x fraction of the work in one day. 6 men can finish 6 by y fraction of the work in one day. Working together, 3 women and 6 men can finish 3 by x plus 6 by y fraction of the work in one day. And how much is this fraction? Well, because they are taking a total of 3 days to complete it, in one day they can complete 1/3 fraction of the work. So this output is equal to 1 by 3rd of the whole work. So we can say that 3 by x plus 6 by y equal to 1 by 3. So now we have obtained a pair of equations in x and y, and we can solve them to find the values of x and y. But these equations are not linear, so we need to make some substitutions to convert them into linear equations. So the substitutions we can make are 1 by x equal to u and 1 by y equal to v. So this will convert the first equation into this equation, 2u plus 5v equal to 1 by 4, and 3u plus 6v equal to 1 by 3. So let's use elimination to solve this pair of linear equations in u and v. So we see that the coefficient of u is 2 in the first equation and 3 in the second equation. So let's multiply the first equation by 3. That gives us 6u plus 15v equal to 3 by 4. And now let's multiply the second equation by 2. So that makes it 6u plus 12v equal to 2 by 3. And now we can subtract these two equations because the coefficients of u are the same in both these. So let's call this equation 1 and let's call this equation 2. And now let's do 1 minus 2. So by 1 minus 2, what will we get? On the LHS, the 6u terms will cancel out. We will have 15v minus 12v. So that's 3v. And we'll have 3 by 4 minus 2 by 3. So 3 by 4 minus 2 by 3. And this will be equal to, so we take an LCM of 12. And we'll have 9 minus 8 or 1. So 3v is equal to 1 by 12. And this means that v is equal to 1 by 36. And now we can substitute this value of v into any of these equations, 1 or 2, to find the value of u. So let's substitute this value of v into the first equation. So I'm writing it here. So we'll get 6u plus 15v. So 15 by 36 is equal to 3 by 4. 15 by 36 in the lowest form is 5 by 12. So this gives us 6u is equal to 3 by 4 minus 5 by 12. So that will be 1 by 3. And this means that u will be equal to 1 by 3 by 6 or 1 by 18. Okay, so u is 1 by 18. So we get u is 1 by 18 and v is equal to 1 by 36. And now we have to get the values of x and y. So x is simply 1 by u and y is simply 1 by v. So x is equal to 1 by u or 18. So this is 18. So one woman alone can finish the whole piece of work in 18 days. And now y is equal to 1 by v. So that is equal to 36. So one man alone can finish the whole piece of work in 36 days. So that's our answer. One woman alone can finish the whole piece of work in 18 days and one man alone can finish the whole piece of work in 36 days. So in part 3 of this question, the problem statement says Ruhi travels 300 kilometers to her home partly by train and partly by bus. She takes 4 hours if she travels 60 kilometers by train and the remaining by bus. If she travels 100 kilometers by train and the remaining by bus, she takes 10 minutes longer. Find the speed of the train and the speed of the bus separately. So this is one of those situations that come up often in speed and distance problems, and solving such problems becomes quite easy if we are able to represent all the given information visually. So let's do that. Let's visually model all this information that's given to us in the problem statement. So here's a figure I have drawn from you. So suppose that Ruhi has to travel from this point X to her home at this point Y, which is 300 kilometers away. Now the problem statement says if she travels 300 kilometers partly by train and partly by bus, if she takes 4 hours if she travels 60 kilometers by train and the remaining by bus. So if she travels the first 60 kilometers by train, so let's say this part of the journey which is 60 kilometers, she does it by train, and then the remaining distance she completes by bus, and this remaining distance is 240 kilometers. Then she takes 4 hours to complete the journey in this way. So how do we represent this whole situation in the form of an equation? So the unknowns in this situation are quite clearly the speed of the train and the speed of the bus. So let's assume that the speed of the train is x kilometers per hour. So the speed of the train is x kilometers per hour, and let's assume that the speed of the bus is y kilometers per hour. So these are the two unknowns. So coming back to this situation that we have, how do we model it in terms of x and y? Well, the first 60 kilometers Ruhi covers by train, and she covers it at a speed of x kilometers per hour. So this leg of the journey she will take how much time to complete? So the distance is 60 kilometers and the speed is x kilometers per hour. So she will take 60 by x hours to complete this leg of the journey. And then this second leg, which is by bus, which she covers at y kilometers per hour, how much time will she take to complete this leg of the journey? So she will take the total distance 240 divided by the speed, which is y. So she will take 240 by y hours to complete this second leg of the journey. And the sum of these two times should be equal to 4 hours because her total journey takes 4 hours when done in this way. So this gives us our first equation in x and y. So let me write it here. 60 by x plus 240 by y, this should be equal to 4. 60 by x is the time taken by the train and 240 by y is the time taken by the bus, and the total time is 4. So this gives us our first equation in x and y. Now similarly, let's model the second piece of information that's given to us. So once again we have this same figure, and the second piece of information says if she travels 100 kilometers by train and the remaining by bus, she takes 10 minutes longer. So if she travels, let's say, the first 100 kilometers by train, so let's say this journey is 100 kilometers long, and then she travels the rest of the distance by bus, and this rest of the distance is 200 kilometers. She takes 10 minutes longer, or she takes 4 hours and 10 minutes. Now, how do we model this situation, this information in terms of x and y? So the first leg of 100 kilometers will take 100 by x hours because it is covered at a speed of x kilometers per hour. The second leg of 200 kilometers will take 200 by y hours because this is covered at the speed of the bus, which is y kilometers per hour. And now the total of these two times should be 4 hours and 10 minutes. So 4 hours and 10 minutes, and 10 minutes is 1/6 of an hour. So 4 and 1/6. So this much time. So this should be the total time of the journey. And from here, we can get our second equation, which we can write as 100 by x plus 200 by y is equal to 4 and 1 by 6, which I can write as 25 by 6. So this is the second equation in x and y. So now that we have found two equations in x and y, all we need to do is to solve this pair and find the values of x and y. But these equations are not linear in x and y. So first we have to make substitutions to turn them into linear equations. So substitutions we can do are 1 by x equal to u and 1 by y equal to v. So this turns the first equation into 60 by x or 60u plus 240 by y or 240v is equal to 4, and the second equation becomes 100 by x or 100u plus 200 by y or 200v is equal to 25 by 6. So now we have a pair of linear equations in u and v. So let's solve this pair and find out what u and v are. So I'm going to use elimination to do this. The coefficient of u in the first equation is 60. In the second equation it's 100. So I'm going to multiply the first equation by 5 and the second equation by 3, because this will make 300 the 60 into 300, and it will turn 100 into 300, and the coefficients of u will become the same. So the first equation becomes 300u plus 240v into 5 is 1200, so 1200v, this is equal to 20, and the second equation becomes 300u and then 200v into 3, so that's 600v equal to 25 by 2. So these are the two equations that we get, and now all we need to do is to subtract them. So let's call this equation 1 and let's call this equation 2. So I can do 1 minus 2. So 1 minus 2, what will this give me? So it will cancel the 300u terms, and on the LHS I will have 1200v minus 600v. So on the LHS I will have 1200v minus 600v. On the RHS I will get 20 minus 25 by 2. Okay, so this gives me 600v is equal to 20 minus 25 by 2, that's 15 by 2, and from here I get v is equal to 15 by 2 divided by 600. If you simplify that, you get 15 by 1200, which is 1 by 80. So v is equal to 1 by 80, and now let's substitute this value of v into any of these original equations and find the value of u. So let's substitute this into the first equation. So I get 60u plus 240v, so 240 into 1 by 80, so 240 by 80 is 3, so 60u plus 3 is equal to 4, and from here I get 60u is equal to 1 or u is equal to 1 by 60. Alright, that's great. So I have found u, that's 1 by 60, and I have found v, that's 1 by 80, and this means that x is 1 by u. X is the reciprocal of u. So the speed of the train is x kilometers per hour or 60 kilometers per hour. and the speed of the bus is y kilometers per hour. And what is y? So y will be 1 by v, and v is 1 by 80, so y will be 80. So the speed of the bus will be 80 kilometers per hour. So our final answer is that the speed of the train is 60 kilometers per hour. The speed of the bus is 80 kilometers per hour. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.